Welcome. This video is really going to be about vertical translations and using that to figure out a log rule that we can use. Okay, so when you're looking at this, Abe says, y equals the log base 2 of x plus b. Is that the same thing here? Log base 2 of x plus log base 2 of b. And that's what we're going to investigate. Now, what do you think? It seems like distributive property. But does it work, really, using logs? All right, because it's a little different with the log function. So if it was to work, maybe an example would be log base 2 of 3 plus 1 would equal, I'm not going to say it does equal, so I'm going to put a question mark, log base 2 of 3 plus log base 2 of 1. So that's what we need to figure out. And some of these are easier to do. This is log base 2 of 4. Okay, and so this is actually, we know that since 2 squared equals 4, then we know that our answer here is 2. Okay, so 2 squared is what will give us 4. Now over on the other side, we don't really know what this is, and we don't really care. Log base 2 of 3. We do know that 2 to a power equal to 3, that power is not going to be an integer. But we do know this. We know that 2 to the 0 equals 1, right? So therefore, log base 2 of 1 has to be equal to 0. Okay? So then the real question here is 2 equal to log base 2 of 3? And the answer is not equal. So, does it work? No, it doesn't work. It doesn't work. So, let's just be clear that it doesn't work. This is not equal to that. So the distributive property does not work the same here with logarithms. And then they look at an example with the graph, and in the graph what you can see is you have the parent function, f of x is equal to log base 2 of x, right? And you can see the points that are on here, and you could graph it something like this, okay? Now, if we take these points, and I always use the same 3 points if I can. If we want to say an exponent of 0, that gives us an x value of 1. If we want to say 2 to the first, it gives us an x value of 2. If we want to say 2 squared, it gives us a value of 4. And what you notice is that the distance between the parent function and the new function is 2. So it seems like it's 2 more. So when we do this, how would you answer a question? Is it possible the equation could be written in more than one way? So this is the way here. But we also know about vertical translation. So find an equation that shows the vertical shift. Well, we could do that. We could start with the parent, log base 2 of x. And then we notice it's a vertical translation of plus 2. So we could write it like this, and that would be accurate. Okay? Let's look at the next one here. It says Mary turned to plus 2. Let's see what happens with log base 2 of 8x, log base 2 of 16x. So here's the 8x right here. And on the 8x, if you look at the distance, you notice that these points are all translated, vertical translation, by 3. In the 16x, when you look at the distance, you notice a vertical translation for these 3 key points of 4. Okay, so then an equivalent equation would be if you use the parent function log base 2 of x plus 3, log base 2 of x plus 4. So now these two equations are equivalent. And then Mary says, oh my gosh, she's figured it out. So this log base 2 of 4 of x is 2 plus log base 2 of x. Well, 2 is really equal to log base 2 of 4. And that's because 2 is the exponent to the base of 2 to get 4. So therefore, log base 2 of 4x is log base 2 of 4 plus the original parent function, log base 2. So this is the parent, and this is the vertical translation right here. Okay? And so therefore, we have a property here where the property is the log base 2 of a times b is equal to the sum. And that's what we saw here. The log base 2 of 4 times x is the sum of log base 2, 4 plus log base 2 of x. So you could say the log of the product is the sum of the log of the factors. That's kind of how I would do it. And we saw an example where that's true. Okay. And you know, if you think about it, 2 to the, say, 4x is equal to 2 to the 4th, okay, times, actually let me change that here, 2 to the 4 plus x is equal to 2 to the 4th times 2 to the x. So there is this addition that's going on with the exponents, and we know that from our exponent rule. All right, so that also is another way to